First, we have Ashley Crawford presenting brown adipose tissue frequency.
Hello, everyone. Today I'm going to be talking about brown adipose tissue frequency. This is in PET-CT. Okay. At the end of this presentation, the audience will be able to define F18-FDG, define PET-CT, describe the function of brown adipose tissue, identify areas where brown adipose tissue uptake is observed within the body, recall how brown adipose tissue is identified, and judge variables based on the effects they have on brown adipose tissue. Okay, so first we're going to start with what is F18-FDG. It is 18-fluorine fluorodeoxyglucose. It's an analog of glucose. And during the PET-CT imaging, this is what's injected into the patient. It's taken up by high glucose metabolizing cells. So this allows us to image the brain, heart, and possible tumors. Okay, and so what is PET-CT? It is positron emission tomography combined with computed tomography. Allows us to see the function, which allows the PET allows us to see the function, and then the CT portion allows us to see the anatomy of the body. So brown adipose tissue is what I'm going to refer to as BAT throughout this presentation from this point on. This is what transfers energy from food to heat within our body. So this is under the control of the norepinephrine released from sympathetic nerves. And this is our non-shivering thermogenesis. So before our body lets us shiver, this is something that's going to help us not shiver. So it's our thermogenesis within our body. And because of this is an unwanted artifact that we do see in PET-CT. So BAT uptake. In images of the PET-CT, we see bilateral and symmetrical uptake of BAT. This is seen in the neck, supraclavicular areas, paravertebral, mediastinum, and suprarenal areas. Okay, so first of all, the point of this research is to identify variables or even groups of people that are more likely to have BAT uptake. This will help improve the clarity of PET-CT images by having the knowledge of maybe what variables cause BAT uptake, and perhaps this would lead to premedicating certain groups of people. So I'm going to go materials and methods. To identify BAT, we would first look at the MIP images, or maximum intensity projection. And then we would go ahead and look at the PET portion of the study versus the CT portion. So I want to give some examples of what BAT would look like on images. Here, this is our MIP image. As you can see, there are bilateral and symmetrical uptake. So to positively identify this or not, we would go ahead and look at our PET-CT images. On your left is the PET-CT fused image. The colored first portion of it is the PET portion. And this means there's high metabolizing cells there. So the brighter the color, the more metabolizing there are cells there. So we see increased uptake bilaterally and symmetrically. And then we go ahead and look at the CT image. So here we would see if there's any abnormal anatomy within the body. So here we would say there isn't like a mass that we're seeing. So this would be positive for BAT. So it's just brown adipose tissue that we're seeing, not possible cancer or anything. So here's an example of a negative BAT identification. There could be symmetrical bilateral uptake here. So you want to look further from the MIP image into the PET-CT images. So again, on your left is the PET-CT fused. The brighter the color, the high metabolizing cells. You see increased uptake. You're going to look again at your CT image then, and you're going to see if there's any correlating anatomy with that. So there are, if I had a pointer, I'd show you, but there's a possible abnormal anatomy there, so it would be possibly tumors. So this would be negative for BAT and positive for possible cancer. So within this study, I looked at 4 different variables. I looked at age, gender body mass index, and an injection to scan time to see if these variables correlate or do not correlate with increased fat uptake. So to do this, I retrospectively reviewed 28 patients, 14 at random positive and 14 at random negative fat uptake. And this is all thanks to UPMC of Hillman Cancer Center of Pittsburgh for letting me retrospectively review their patients. So within the findings here, I kind of charted this for you for how many patients had fat uptake and how many didn't. So the age, so someone between 23 and 75, we saw a fat uptake. Between 50 and 84, no fat uptake. There's not really a positive correlation there. It's too close to, within my research, to say that's a positive or negative effect, the variable of age. So I saw the same within age, BMI, and injection to scan time. I didn't see that there was a large correlation there. They're too close to compare that way. So then I looked at male to female. So I found that there was a large correlation with females having greater fat uptake than males. So as you can see, 1 out of 6 males had fat uptake, but 13 out of 8 women did. So that was the best strong correlation I had. So I want to again just let you see how close in the age, BMI, injection to scan time, how close they were with and without fat uptake, so it's not really prevalent in this research. Okay, and then, like I said, I want to invalidate age, BMI, or an injection to scan time as being increased or decreased fat uptake within patients, but it did demonstrate that gender, females had increased fat uptake. So maybe that's something you would see an image, a radiologist, and you would look further into those, or maybe possibly pre-medicate more females that fit to a category. But improvements I would do on this research, of course, increased amount of people, patients would definitely help validate or invalidate more variables, more strongly do so. And I would also, looking back on it, knowing that patients do wait between 45 minutes to an hour between injection to scan time, maybe those 45 minutes compared to 60 minutes in a warm chair with a warm blanket in a warm room would affect that, because we do know that that is affected by temperature. But this, again, was all through the same hospital, and they all sat within the same room with the same warm blankets, but the room temperature could change, like, significantly, but maybe it would have changed the results here. So I just wanted to go ahead and give a special thanks to my teachers, Hillman Cancer Center, and their amazing work crew there. They really helped me do this, and without them, I wouldn't be able to get any of these results. Thank you.